MEM School of Engineering, Department of Mechanical Engineering, online classes, subject mechatronics, unit number 5, case studies. So, last class we discussed about two case studies, that is wireless pick and place robot and engine management system. Okay, these two are dependent on the microcontroller and the processors. Okay, now we are going to see about the PLC case studies. Okay, already we in unit 4 we discussed about programmable logic devices. That is programmable logic circuits. Okay, so that we are going to implement the some application using the PLC. Okay, let's see the case study. That is automatic car park barrier system. That means in most of the countries they have automatic car park barrier system. Okay, they are fitting for they are, if you are, they are rent the places for traffic process. Okay, if you put 100 rupees for in a parking system, so it will calculate the all the barrier system. If you when go for the some other barrier means some other land means it will be product by the some barriers. Okay, that is total. If we in a car parking system, if we have 8 LAN means the total LAN will be connected with a common PLC controller. That means the whole number of actuators, that is motors, are connected with a common PLC. Okay, that concept we are going to discuss in this unit, chapter. So this is the PLC based automatic car park barrier system. So consists of the following main components. That is batteries, barriers, electric actuators, that is solenoid valve and the limit switches. So hydraulic actuators, single acting cylinder, and a PLC. Okay, these are the concept. So first one, barriers. So there are two types of barriers: in barrier and out barrier. Okay, in barrier and out barrier. So in barrier, it is located at the entry of the car park and is used to allow the car in the opening when the correct money or coin is inserted in the cash box. So it is pivoted at one end and controlled with the two solenoid valves, A and B, which are associated with a cylinder piston assembly. A connecting rod connects the pistons and the barrier as shown in the figure. So that is in the figure. They have cylinders, pistons, solenoid valve A and solenoid B, and the upper limit switch and the barrier and pivot connections are fixed in this concept. So it is located at the exit of the car park and is opened to the let the car go, and when the car is detected in front of it. It has similar arrangements of solenoids and limit switches as that of the in barrier. So next concept is solenoid and limit switches. So there are two solenoid valves A and B as mentioned above. So which are used to move the piston upwards for opening and downwards for closing of the barrier. So there are two limit switches. One is placed at the top of the edge and the other is placed at the bottom edge of the barrier. So detect the position of the in barrier and the out barrier. So when the current flows through the solenoid A, the piston in the cylindrical extends to move upward and causes the barrier to rotate above its pivot and thus barrier. So allows the car inside. So when the current flow through the solenoid A cases, the springer and the solenoid valve make the contacts to open and thus makes the valve to its original position. So when the current flow through the solenoid B, the piston in the cylindrical moves downward and the case causes the barrier to get down. So limit switches are used to detect when the barrier is down and also when fully up. So PLC, so coin operated switch. It is having the input module and output module. So already we know that PLC having different kind of n number of input modules and n number of output modules. So input modules are coin operated switch, entrance barrier setup. So entrance barrier switch down, input when car at exit barrier up switch, exit barriers down switch. In output side, they have entrance A, entrance B, and exit A and exit B. That is for actuators. They in the connected in the output module. Then X40, so X400. That is coin operated switch at the entrance to the car park. So these are the pin connected with the particular application, particular input. Okay, 6 inputs X4002, X45 is required for the PLC to send the 6 limit switch position, namely coin operated switch, entrance barrier up switch, down switch, car at exit barrier switch, exit barrier up switch, exit barrier down switch as indicated in the diagram. Whenever a switch is operated, so 0 volt signal is provided to the corresponding input and otherwise plus 24 volt signal is provided to the inputs. So 4 inputs are required to operate the 2 solenoid valves A and B. Okay, these are the construction ladder diagram of the barrier system. These are the ladder diagram of the barrier system. Then we'll see the operating steps of barrier system. So these are the steps. The car enters the car park. The driver insert the coin to the cash box. In barrier opens and let the car enter to the park. The in barrier closed subsequently. The driver parks the car and leaves the park for his work. So after driver's work is over, he returns to the car. He drive the car to the front of the out barrier. Okay, the out barrier open and lets the car to leave the park. The out barrier closed subsequently. The cycle then repeat for the next car. So this is the simple operation which is done in the electronic car barrier system. These are all controlled by the common logic. Okay, so this is simple logic. Okay, here we have trails and rungs we have. So that is X400 is a normally open condition. M100 is a normally closed condition. So Y430 will be the solenoid valve A for entrance barrier. Okay, so like that. So these all the conditions are done with the direct some logic. So first one is done with the XOR logic. So second one also direct logic. That is if X401 is enabled, that is if there is power supply means, so it will execute the T450, that is M100. Like that they will explain. These are the concept. So finally it will produce the end. This is the ladder diagram for car barrier system, parking barrier system. Okay, these all the conditions are controlled by the PLC because PLC provide the high power voltage, that is it can work in the 230 or 440 volt. This is the main advantage of PLC used in this condition, electronic car barrier system. Okay, so I hope that the both case studies are very useful for your future considerations. Okay, that means and finally I can conclude with that the mechanical system is controlled by the electronic unit, that is mechatronics, which is cover more industry operations. Okay, so it is a very useful topic for your future studies. Okay, so okay, thank you.